we are provided with this rational function, and I chose to expand. So x minus 2, I wrote down twice. We can see it has a multiplicity of 2. The same thing in the bottom. X minus 4 has a multiplicity of 2, and I expanded it here. Oop, forgot to write that twice. So x minus 4 will be written twice. Now I'm going to go ahead and I'm going to simplify. So x minus 2 and x minus 2 simplify to 1. That means there could be a hole in the graph at x equals 2. And x minus 4 and an x minus 4, that means there could be a hole at x equals 4. The remaining factors I'm going to set equal to 0 in the denominator. So x plus 3, set it equal to 0 and solve. And we have one vertical asymptote at x equals negative 3. Set x minus 4 equal to 0. We have a secondary vertical asymptote at x equals 4. Now notice here that we have both a hole before we analyze this at x equals 4 and a vertical asymptote at x equals 4. There's not both that will occur. When you see a duplicate value in both categories, the vertical asymptote will always trump. So we have one hole at x equals 2 in the graph, and the vertical asymptotes will be at x equals negative 3 and at x equals 4. Now mathematically speaking, there could be another way to explain this. This is what I believe is the easiest way to understand it. Mathematically, we could say the multiplicity of the real 0, 2, is greater in the numerator, there's a multiplicity of 2, than it is in the denominator, which has a multiplicity of 1. And when that occurs, we can say the graph has a hole in this rational function at x equals 2. For me, it's easier to expand and simplify, and then again, when we see a duplicate, vertical asymptotes will always trump.